So hello everyone. We are going to be talking about a very, very interesting topic today. And before we go ahead, I'm going to ask all the panel members to please introduce themselves. And we have an esteemed group of panelists who are veterans in their own field. So we will start with Shalini. Shalini, if you can just introduce yourself.
Hi, I'm Shalini Kapoor from IBM Software Labs. And I am an IBM fellow working in AI. Artificial intelligence is what I build, I create, and I talk about to everyone around me. I build products and have worked on AI infusion on products across our portfolio. That's all.
Thank you, Shalini. We move over to Aruna now. Aruna, if you can introduce yourself as well.
Yeah, I'm Aruna Rao. I've been working in technology for financial services for last 3 decades. For the last, say, 12 years, I was the CTO for Kotak Mahindra Bank and its group companies. And over the last couple of years, I've been advising them on strategic technologies. And of course, AI and machine language, cloud, cybersecurity are all tied up together. And those are the areas that I have been really focused on. So implementing AI, ML for financial services has been my focus for the last couple of years.
Great. Thank you, Aruna. Sridhar, how about your introduction?
Hi, everyone. This is Sridhar Turaga. I'm responsible for data science and digital innovation business at Citius Tech, which is a large healthcare services company. I spent the last 8 to 10 years focused around applying data science, AI, ML into businesses across industries, but currently focused on healthcare. So thank you.
Thank you. Thank you all. As we all know, we've heard a lot about the esteemed panelists. And over to me. So I'm the moderator for today, and we have a very interesting topic at hand. So the topic that we have at hand is ethics and AI, and of course, more importantly, the biases that we have insofar as algorithmic biases, as well as the other biases that we have. So we will start off with the questions, but more importantly, all of us should understand the fact that we have evolved insofar as technology is concerned, and technology has played a very, very large part in our lives. So in every sphere. So it is important for us to understand that we, apart from the normal biases that we have in society, we also have the same which pertain to algorithm. So let's start off with a question. So the first question that we have over here goes to Shalini. Shalini, if you can just help us understand, how does the bias creep in, and from the data scientist or the society? So there are two parts of the question. If you can just help us understand both. Yeah.
Sure. Bias, there is a lot of myth that biases are created, and the data scientists are putting all the biases inside the algorithms. That's a big myth, because bias pretty much exists in a society. It's how we perceive people, how we perceive the various how our perceptions of society is, and how we have ethnicity or gender or culture related perceptions in our mind, which get carried over. And data scientists are humans. All the models are created by humans. So the bias creeps into our algorithms when we have fed the data. There's a lot of bias in the data itself which is present, right? When the data is, it could be data about the set of people that for whom we have collected the data. It could be restricted to a certain geography. So if you're creating a model for something which is a global model which applies to various sections of society, it won't, because the data is fed into it, say, of 40-year-old males, right? So it will never have the right recommendations for women. It will not understand the context in which it has to change itself. So the bias happens because the data could be biased. There are biases in the person who's building it and is making it only for that particular person. And also when the model is running and the model is in production, at that point of time, you have not oriented it to a different set of society. So you continue to feeding data to certain, you continue to feed data which is of similar nature. There is no diversity in the data, right? So that is when the bias starts creeping in, and hence when the output comes out, and and there is a classical example of a loan being given to a certain section of society just because the data has been fed, and that's how the loans were given at a previous point of time. So it won't apply to all. So these classical problems come in because of the data, because of how you run it, and you continue to operate it in a certain environment, and also all related to the people who built it. They have certain intentions for it. For example, if a car is driving and you're putting models into it, the car manufacturer is the creator of the model, then that car manufacturer will always protect the person inside the car, right? And there are people who might be crossing the road and they might be wrong. So it will not be favored towards the pedestrian. It will be favored because that's what they are built for. So the intention sometimes drive it, right? So how do you create the models and how you have a 360-degree look around it? That needs to be seen by the organization so that, all these biases can be mitigated and not built.
Thank you so much for that, Shalini. That was very well answered. Now moving over to Aruna. Aruna, if I may ask you about, continuing from where Shalini left, and that's another leading question from that comes to my mind, and which is that insofar as the industry is concerned, there are a lot of situations where we have, I'm sorry, there's just one small little thing that has come up. I'm sorry about that. Yeah. So my question to you, Aruna, is: do you think that in the banking sector, since you're part of the banking, you've been part of the banking sector, when it comes to questions like who should be given the loan, is it based on certain biases and which are actually fed in the design stage of the algorithm? Is that where the problem lies? What are your thoughts on that?
Okay. So like you said, I'll take off from where Shalini left off. As she said, no data scientist intentionally feeds in the bias, okay? But because the data in the environment is indeed of that nature, or the sample set of data that is taken to train the model may be, weighted in one direction or the other, it could indeed develop a bias in it, or the design of the algorithm may weight a particular feature or an attribute of the model, which could result in a possible bias. And, I've come across a good example of this for the financial services area. There is a researcher, I think her name is Dr. Sweeney, and doing research at Harvard, she identified that an algorithm that was used by a direct marketer to decide what kinds of advertisements to serve up to somebody who was surfing on the internet, found that the algorithm actually discriminated against people of color, that is, people who were not white in the audience. And they actually found that it would consistently serve up offers of credit cards which had a higher interest rate, a more pricey credit card to the people who were browsing and who were people of color, was what it was doing. And this is absolutely, a great example of bias in financial services. And, it is very unfortunate because, of course, the receiver, the person getting that advertisement, is biased against because they're getting only certain kinds of offers of credit card. And the financial services organization also is actually not getting a good deal, because the organizations who want to offer better interest rates to be able to actually tempt those customers into taking their credit cards and not getting their offers served up. So it's not good for either of them, either the organization or the individual. So this is not intentional. Now you can ask, why does it happen? And I think it's similar to what Shalini said. It is because there's probably some kind of bias in the data out there in the environment. Probably when the model was trained, it had a lot of data of credit card users who have got very high interest rates, and the credit cards were owned by people of color rather than white people. And the white people had credit cards where the interest rate was lower. So it probably had that trend in there. But normally what happens is these AI algorithms will accentuate, and in their attempt to generalize to a wider population, it will increase this bias. So if there is an X% of bias in the data, it's probably going to give you X plus Y when it starts making those predictions. And that's probably why it happened. So can it happen? Yes, this was actually a situation which was found, but it's certainly not good for either the customer or the organization. And we really have to find ways to guard against it.
That's a very interesting observation that you made, Aruna. In fact, I recall this incident where, one of the organizations had gone ahead and done an algorithm actually had detected the speech of two commentators where they were talking about black and white chess pieces, and they banned the organization for 24 hours, and they lost revenue for that just because of it was considered as hate speech. But later on, of course, they got it back all sorted. So Shridhar, moving on to you, I think very, very interesting conversation that is building up now, and I will touch upon these very important aspects, from where Shalini and Aruna have actually given a lot of light into it. How do we actually go ahead and detect algorithmic biases, and how to realize that an algorithm bias actually exists in nature? So if you can just throw some light on that.
No, thank you. So I'll maybe just put a distinction between bias and fairness as we move the conversation forward, because I think fundamentally all human beings and all algorithms are biased. And I think it's a question of whether you can tolerate the bias and whether the cost of the bias is acceptable to you or not, right? So to begin with, I think bias is unavoidable in some ways. Fairness is, I think, where it gets much more complicated, because fairness is an element of social and contextual aspects into this, right? So I'll just keep that distinction as we talk about it. I will make a general argument that, on this topic of bias, because of AI, you could argue it both ways. And honestly, I think we should just accept that we don't understand it fully as human beings at this point, honestly. I think one argument is that you could make that actually when human beings make decisions, it's very hard to track the bias in their decisions because it is in some ways subjective and not as tracked. So you could actually argue that because algorithms are now making decisions, it's easy to catch the bias and measure it, right? That's one argument you could make, that actually all of this focus on bias is coming because it's algorithms. If it were humans, they got away with bias for a very long time, right? Even today in parts of this country, it's okay for a girl child not to wear slippers to school while her brother will wear slippers to school. We get away with it all the time. Poor AI is being blamed for what we do as a society. The reverse argument could also be that probably AI as a technology is progressing so quickly, so much faster than we can control, that we don't exactly know how some of these algorithms work. In fact, the most popular deep learning algorithms are not understood by us as to how they make decisions. So I will just make this argument that it can be measured, but many of the algorithms that have become very popular are not very explainable. So I think this is a tricky situation. And the other aspect from fairness perspective is that I think that's where I think algorithms and data alone are not sufficient. I think other societal norms have to be applied to bring in fairness. So I think that's kind of one way to think about it.
Sure. Thank you so much, Sridhar, for your point of view. And now, let's dive a little deeper and try to understand, the the certain questions which are pertaining to the build-up phase of the algorithm, that may perhaps help us solve the problem. I'm not just saying solve the problem, but at least mitigate some of the biases which do exist. So Shalini, starting with you, what is the mitigation process that may, being with IBM? So you would have come across certain issues, and of course you would have addressed those at the leadership level. So what are some of the mitigation processes that you can probably talk about, maybe not from your organization, but in the industry that you are part of, and what can people do about it?
Sure. So I think first I would like to, also talk about and continue what Sridhar mentioned, that bias is very dependent on how the perception is, right? And bias and fairness are a different term. And I would agree to that, because we also talk about trustworthy AI. We say that the AI, when you are building the AI, it has to be trustworthy for the person who's building it, right? So it could be an enterprise, it could be a consumer, it could be a single person, building a model for themselves. It could be a large organization, but you should be able to trust the outcomes of it. If you're not able to trust the outcomes of it, that means it is biased. Now that bias could be human related, or that bias could be actually in the way it is giving its decisions, in the way it is favoring a certain decision more than the other, right? Which is not necessarily caused by a human intervention. So the trustworthy AI is extremely important for us to look at. And how we do it is that we work on several to mitigate the biases which could have crept in. We look at mitigation steps at every point, like if it is data, right? So we look and we identify, and we have certain bias mitigation algorithms which we have in fact put up in open source. And they are, and we also look at, also what Sridhar pointed out was that we also look at explainability, right? It's not just that you have to look, when you're doing trustworthy AI, you also have to explain to people why that decision is made, right? So you might say, shut down the machine because we know it's going to fail, right? Very, simple. So it could have been caused by very temperature change or weather change or whatever, right? But you have to explain it to the user that why that decision is better than something else. So that also is a bias mitigation mechanism, right? So what we have done is that we have created a lot of algorithms at every step, and we have contributed all to open source. So we have something called as AI 360 explainability kit, AI 360 fairness kit, AI 360 bias kit, in which we have actually a set of algorithms, and we say, and we tell all our folks in the industry that please feel free to go and use them and apply them to your existing algorithms. Now, some of those things are about the data itself, that in the data you look at the predictions it is giving, the groupism that it has. Is it individual distortion which is happening because of a lot of individual features? Is the outcome getting transformed because of certain groupings that we have done? So there are various methods of doing it, and there are all these methods we have clubbed together, right? So, and this open source toolkit that we have, which handles bias and machine learning models, it actually has 70 fairness metrics, right? And it has like 10 bias mitigators, and it has like we have a lot of industry tutorials around it, that if you want to apply it to banking or to manufacturing or to retail, this is how you go about it. So essentially what we are doing is we are saying, and they are pretty much Python API docs, which you can get the Python code, you can get the R code, we also have it in that, and you can use it and you can improve it. So it's not just one, there are several there are 70 fairness metrics that we are talking about. So these are the state of the art bias mitigation algorithms, and they are developed by the research community and given up pretty much out in open, so that from the lab you can do an actual project and you can practice in your domain.
Absolutely, and that's a very interesting perspective. In fact, from an outsider, it may seem that the bias has actually been planted by an individual or by a group of individuals. But the reality is pretty much different, and the job of the leadership and of course the people who are responsible for making that algorithm is much different. So thank you for that, Shalini. Moving over to you, Aruna. The question that I have for you is where perhaps we may have in the banking sector, the sector that you've been part of, and you're a veteran at that. Given the strict regulations, how do you build a model? How do you test it? And how do you put the same into production? So what are the entire steps, so to speak? I know it's a very long question, or rather 3 questions, but then, yeah, would want to hear from the horse's mouth.
Okay. So it is similar to what Shalini said. She gave us some mitigation methods to ensure that we're not, building any biases. So I think one of the additional things we can do is when you inspect the data, which is going to be used for building the algorithm, I found my own personal experiences that you should not just look at this as a data science exercise or a logistics or statistics exercise. You really need to look at it from the perspective of the domain in which you want to solve the problem. The people who understand the domain should really look at it and inspect it, because only they can determine if indeed there is, a kind of problem over there. I actually had an experience once when we were building a machine language algorithm for predicting, a potential fraud situation. And, we ran the algorithm, and what had happened during the period of time was that the business had changed the business process for 1 or 2 of the products that they normally run. And therefore, it was not storing data for those particular products. Now, obviously, the machine language algorithm had determined, was biased for those particular products, either, for it or against it. And it would potentially give us incorrect fraud detection kind of information. So unless you have somebody who really understands the domain of the data and then corrects for it or makes whatever balancing that needs to be done, I think that becomes a problem. So that's one of my learnings. And the second big thing is, really the biggest problem, and I think you all sort of hit upon it in different ways when you said, is it really trustworthy? Because some of the models which really perform the best are not explainable. They cannot be explained, right? So for us, it's always a trade-off. Shall I take the explainable model, which probably gives me suboptimal results? Or when I say suboptimal results, I mean from back testing, which appears to perform less than the others. Or shall I go with the more, unexplained ones, which really gives me what I'm looking for? And that's a very tough decision. And it is that's where it becomes an art, actually, and an entrepreneurship kind of thing. It's the decision making. One thing we can do to mitigate the whole risk, which we do, is we run it in what we call parallel for a long time. Anyone in technology understands what that means, right? You keep running the old system. If it is a manual system, then fine, manual. Or if you have another conventional technology which is helping you predict whether you should give loans or not, then keep running that old-fashioned way, and then keep running machine language for a longish period and see if it is throwing up biases or any other kind of problem. But then you really have to take that leap if you're going to use the unexplainable model. So I would love to hear from all of the other experts if there is, better that we can do in this way, because I've found that in the end, it does become an entrepreneurial decision on how much risk one should take to be able to leverage that unexplainable model.
Aruna, I don't have anything better to say, but I'll add to what you said, which is I always tell customers that think of your AI algorithms the way you parent your children. Okay, just like your children are growing up and you protect the influences that shape them, please think about your algorithms and the influences they are having, because they may grow up to be something you don't want them to.
Very true. So you need to nurture them all along the way.
But then you have to give up, right? Then you have to let go. Then you have to let go. And like the kids, the algorithm will do what it does.
Yeah. No, that's an interesting parallel that you've drawn, Shridhar. Thank you for that. So moving on to some of the more interesting, and I think this is now leading us to a very, very interesting part of the conversation and of course, what the topic is all about. So Shalini, the next question is for you. there's a strong possibility that you might mitigate one kind of bias, and while another kind of bias might just creep in at the same time. How do you handle such a problem? Because, it's an ongoing process.
Yeah, yeah, it's definitely an ongoing process, and you can always do multi-factor bias detections and have various variables and look at them, but then you have to mitigate them one by one, and also do it on a continuous basis, because enterprises, see, what happens is that the end, and I think Aruna talked about it, the business process changes, right, and the business decisions change within the organization itself, right? That how you, on what basis you are taking a certain decision, the constraints keep changing in the variability of that keeps changing in. So you have to change the algorithm, and monitoring of an algorithm is a very continuous, and it's a very important time, because the most of the time people think that the build is what they have to focus on. Monitoring will, it'll live its own life, right? So like Sridhar said, you can't let the child let go, right? You have to keep monitoring and keep seeing. But yeah, but that monitoring is so important, that you keep checking on the biases, which new biases might come in, right? Suddenly it might and it's all because it's the data which is getting fed into it, right? It's a new data, new environment, it will behave in a different manner. So, and that's why the human mind is so different, right? We adapt ourselves to and our ethics evolve according to the situation that we are in. The ethics that we have maybe in a corporate setting, and the ethics maybe at my home, I might say something, but I might not say it in a corporate setting. I might say that in a get together with friends, right? So our mind adapts so fast to what the environment is. But the algorithm, you have to keep teaching it. You have to keep making it learn with new sets of data and new, sets of things. In fact, I was talking about, we did a very interesting bias study with on Bollywood, right? And we tried to find out that, of course, I think all of us know that Bollywood is biased, right? It is biased, but through algorithm, we actually proved, and this is the one we did with IIT Delhi. Our research lab did it, and through algorithm, we, and through study of the posters of pictures, the songs, the dialogues, the amount of dialogues which are covered, and there was a sheer bias that the number of dialogues that a woman gets in a movie are so less, but in every posters there are, in this, if you do image scanning and you have a look at that, there is only that 80 to 90% is going to be women who are on the poster, who are not. I mean, we know that, right? It's not that we don't know it. But now you have an algorithm which is telling you, and you have a system which is telling you that it's inherently biased. It's detecting it, right? Yeah. So this kind of mechanism, you can detect more kind of bias. That every time a nurse is referred to as she, a doctor is referred to as he. Absolutely. Right? So, yeah. If you bring this out and you talk about this, then people are more sensitive to it. They ensure that these things are not done, because, there has been an algorithm which has proved that there has been a bias. So sometimes, you use the algorithms to learn yourself, and you come back to the society and say that, yes, there are things happening. And yes, you have to keep monitoring it in your enterprise to, for new kind of revelations that you might get.
Very good. Thank you so much, Shalini. That Bollywood example was a classic one, at least for our millennial audience. I'm sure they'll be happy with with that part of the debate. So great. So moving on to Aruna. Aruna, my next question is for you, and this is a very important one at that. When it comes to, do you think that there is a myth that needs to be busted, that in the AI, that AI is actually responsible for algorithmic biases, because it is clearly the creators that need to be better trained before building an algorithm, so to speak?
We've been talking that the biases come into an algorithm for different reasons. One could be the data. A second could be the design of the algorithm. A third could be the sampling, which is also part of the data. So it could either be unintentional or intentional. So I'm keeping the intentional piece out. I don't think, for a moment that really is happening. But we know that it is creeping in unintentionally. So I don't think anybody is doing it deliberately, but we've talked about so many different mechanisms to try and prevent that happening. And one additional thing possibly we could do to even mitigate for the unintentional stuff that's coming in is to see what your AI team is looking like today. Build in the diversity into your AI team. If you think that a particular section of society is likely to have an unconscious bias, towards women or against women, then make sure there are as many women or men in that organization. Make sure that there is diversity in your AI team itself. So even that unconsciousness, can be mitigated a little bit. So of course, we use the tools that Shalini talked about, the AI 360 fairness. I think Google has got also something that we call, it's called WiT, just like WiT-ACE, but it is like a what if tool. So you can, look at different scenarios by changing the data sets and things like that, and see whether the tool is, whether the algorithm is going to be biased in certain situations. But I think, the other thing we can do is to try and, of course, first make everybody aware that there is such a thing called a bias, and it does happen, whether you like it or not, in an unintentional way. And then try to mitigate for it with having a diversified team building your AI.
Can I just add to that? I think this is an interesting point you're making. I think there is a few other factors I think are also at play here. Firstly, I think that, while this AI ML is an interesting trend, the bigger trend is that all of these compute capabilities are being democratized very quickly. It is unimaginable 10 years ago that you can get the latest algorithm, have the compute capacity to run it, because in the past, it was only a few select experts who had access to it. But like the proverbial story of the monkey and the sword, I think sometimes giving access to powerful technology to too many people means you apply it badly, right? So there is an element of, we may be democratizing it too quickly, and we may be sometimes unknowingly introducing problems because you have super expert capability being run by people who have not spent enough time understanding it. Second thing I think is that society in general has not caught up to this. If you think about, take even the best university in the world, you look at a political science course today, people who are studying political science, I don't think they're studying how elections are being manipulated by Facebook. But it is a fact, all our elections are being manipulated on Facebook. So political science requires to catch up with the fact that AI is being used to manipulate elections. So I think if you look at any field, economics or history or even regulatory expertise, right? They're not caught up with this technology because they have a role to play. To your point on diversity, how many AI teams think of having a non-computer scientist as a part of the team? Having somebody from a non-science background, because these are affecting human lives and our society, right? I think maybe those aspects have to be thought about as well, that we have in some ways not caught up to the power of this technology, and we've spread it too quickly, and many parts of our society are coming to grips with it. And I think that if it is left solely with technical people, I think it will not be as fair as it needs to be. I think bringing in non-technical people, the non-computer scientists into the world of AI is very critical, I feel. And I think that's something we have to think about from a regulation, society, education perspective.
Thank you so much, everyone. It has been a wonderful and interesting discussion on the topic. And I hope to hear from all of you more on this. To sum it up, I think there's a lot that needs to be done from both sides. And of course, from the outside world, it may appear as though there is a bias. Of course, there are biases which exist. And there are problems which need to be delved into on a more deeper level. But the more important part is that there is also a think tank that exists in every organization which actually looks into it and tries to solve those problems as they come up. And of course, when you solve one, you may have another. So it's an ongoing process. So wonderful. Thank you so much, Shalini, Aruna, and Sridhar for spending time with us for this wonderful, wonderful topic. And I think we look forward to hearing from you soon in our other segments as well. Thank you so much.
Thank you.
Thank you, Manmeet.
Thank you. And nice
Thank
meeting
you
all
for
of
having
you.
us. Same here.
Bye.
Bye.